Okay, in the previous class, we have solved some of the question, right? So in again today we have solved some of the problem. In today's class also we will solve two problems, and then your tachometric surveying will be finished, right? In today's class, hardly, and again there is a small theory part is there in your tachometry. If we cover that, right, that we are going to cover it on Monday's session, right? If we cover that, then tachometric survey is going to be finished. So your 1.5 module completely it will be finished by your Monday. So now, without having any delay, we will start with the problem, right? In today's new problem, we are going to have in the today's class. Okay. So here in today's class, we will be seeing, right, the tachometric survey, your tachometer was set at A, and the readings on a vertically held staff, right? Now, in this particular problem, what we are going to do, we are going to have, right? We are going to have the tachometer at station A. So this is your station A, okay? And then, and the reading was taken vertically held staff B. Sorry, this is the last problem, it seems. Just a minute. This is the last problem what we have solved it. Just a minute. I think this problem has been already solved. Now, today we are going to have just a minute. This is the problem, it seems. Just a minute. I'll share it in your class group itself. Yeah, this is the problem what we wanted to solve in today's class. Just a minute. I'm going to start it. Yeah, this is the problem what we wanted to solve in today's class, right? A tachometer is set up at an intermediate point on a traverse course PQ, right? An instrument was set up an intermediate point. So intermediate point is nothing but the in between point between the two stations, two staff stations. These are the two staff stations. And here a tachometer is set up an intermediate point on a traverse PQ. So one staff was held at P and the another staff was held at Q. And the following observation are made on a vertically held staff, right? Now, staff station, that is staff station, this is data is already given in your problem, right? Staff station is P and Q. So P, it is going to have a vertical angle. If you look from the tachometer, right? If you look from the tachometer in between, right? If you look from here, right? You are going to get an angle at P is, right? At P is, you are going to get 8 degree 36 minutes. So this is what 8 degree 36 minutes. And the staff intercept, that is staff intercept is nothing but you are reading from the top stadia and the bottom stadia. So that yes is given as 2.350. 2.350 it is given to you. And then your axis hair reading, that is your crosshair reading, the center crosshair reading is 2.105. So 2.105 is written over here. My screen is visible to you all? Screen is visible to you all?
Yes, sir.
Okay. Okay, fine. So here it is 2.105. So this is your center crossstaff hair reading. So it is 2.105. So if I look from Q, right, as you know that here, since it is 8 degree, there you can clearly see that this elevation is different and this elevation is different. See, after getting this particular data, how you are going to write down or how you are going to draw your figure is going to be very, very important. See here, 80 degree means it should be higher. P should be higher than Q. You should understand it. By common sense, you should understand it, and you should accordingly you should draw the diagram. Okay, so C from Q is going to have angle from instrument station. If you look at Q, it is going to get an angle of 6 degree 6 minutes. Staff intercept, that is S, we are going to have is top here STDR reading and bottom STDR reading. S difference is 2.055 and central axis here reading is 1.895. So this, by this particular data, you should be able to draw this particular diagram. Okay, you should be able to draw this particular diagram. Then the instrument is fitted with an analytical lens and the constant is 100. So K value, they have given it as 100. So K value is, they have given it as 100. Compute the length of PQ, right? The distance between PQ, this is, here is P, here is Q. They want to calculate the distance between PQ and the RL of Q. They want to calculate the RL of Q. They have asked to determine what is the distance between P and Q, and they have asked you to determine what will be the RL of Q. Is it clear? Is the problem is clear?
Yes, sir.
Okay. Now, and they have given this P, right? They have given the P RL is 321.50. They have given the RL of P is 321.50. They have given it to you. Okay. So now let us see directly towards the problem. We will go directly to the problem. See, you people, what is the time now? It is already 1:43. The people are entering till now. So it is not the thing that has to be. So straight away from next class onwards, I won't look towards your meeting admit and all those things. I will not entertain this. Okay. So this is what your diagram is. This particular thing we have drawn it over here, right? So this diagram, before solving any of the problems, the diagram is going to be very, very important. If you go wrong in drawing these diagrams, then you will definitely you will make mistakes in your solving the problem. Okay, next is, now here what we are going to do is, right, we know what is the elevation of P, right? Now what they have asked the distance PQ and they have asked the elevation Q. So I need to find out what should be the D value and what should be the distance between the instrument station and the distance between P and the distance between this and this. Then only I can find out what is the total distance between PQ. So we will see only towards this particular side from the instrument station to the point P. Okay. Now here from the instrument station to the P, we are going to see it. Now what data we already know is, we already know what is staff intercept, right? That is 2.350, and what is the angle, right? And what is K value? This we already know it. So S is 2.350, which is, I have written it over here, and theta is 8 degree 36 minutes, which I have written over here, and then I know already what is the K value. K value, it is already given over here. So this is what we already know it. So what I first want to determine, I want to determine the distance between the instrument and the point P. So with this particular data, I can able to easily determine what is the distance D. Since C is not given, we will take directly it as 0, right? So what is your formula? Ks cos square theta plus C cos theta is your formula, but C is not given, so directly we will take it 0. So K, we are going to substitute it as 100. Yes, we already know it. And cos square theta, we are going to have 80 degree 36 minutes. So from the instrument station to this particular point, we have determined the distance D. The distance D is 229.75 meters. So here we have written it as 229.75 meters. Now we want to know what is V. Formula we are going to have is Vs sine 2 theta divided by 2. we are going to have. Okay, so here we will be again in this last problem. We have done c sine theta, we have done it, but c is not given, so that is the reason why we are not doing. Actual formula is v is equal to ks sine 2 theta divided by 2 plus c sine theta, but here c is not given, so we'll again directly take it as 0. So ks sine 2 theta divided by 2, 1 by 2 we are going to take it outside. Now k is 100, s is, we already know it, 2.35, sine 2 into theta is 8 degree 36 minutes. So if we simplify the vertical height, the center reading, your center crossstaff reading, right, central crosshair reading, and with the your horizontal line of sight, with the line of sight, what is the difference we are going to have is v is 34.745 meter. So this we already determined it from, this is how we have put it into the diagram. Then difference, we want to know what is this particular height, right? What is the difference between this level and what is the height of this level as compared to v? What is the height of p? We need to have it. So here difference in the elevation between the instrument and, right, with the instrument axis and the staff, what is the difference? We needed to know it. So the difference, that is v minus r, the difference between this, right, between this and this point we want to know. So the difference we can determine is this, we already know it, it is 34 from here to here, 34.745. Then we, if we do minus this, then we will be getting the p, right? Then we will be getting the p value. Okay, so p will be v minus r. So v is from this to this and minus r is from this to this. So we will be getting this particular height. So from your horizontal line of sight, difference in the elevation between p and the instrument axis is, it is 32.64 meter. It is 32.64 meter. So p is higher. Okay, the difference between this point and this point is, right, this point and this point is 32.64 meter higher. Now we will, is it clear? Is it clear?
Yes,
yes.
sir.
Is it clear to all?
Yes, sir.
Only A division
Yes,
students are
sir.
replying.
Yes,
What
sir.
about B division? What about B division? B division, anybody? Have you understood?
Yes, sir.
Okay. So I can move ahead. Can I move ahead? Or if anybody wants repetition, I will repeat it. Can I move ahead?
Yes, sir.
Okay, fine. So this is, we have determined the height of P with compared to this particular height from the horizontal line of sight. We have determined it. Now we will see, right? We will see what is, how we want again the distance between PQ. So we have to determine this D. So how this D can be determined is, right? So we need to look towards this particular point now. Okay, this is over. We need to look towards this. Now we will see, right, observation from the instrument to Q. So what is S? S is already given. It is 2 point, the difference between the top and the bottom crosshair, it is 2.0055, which is already given over here. Then we are having a theta value, that is 6 degrees 6 minutes. Theta value we are having, and then we are having the axis hair reading, that is 1.895. That is the crosshair reading, 1.895. So from this we can determine, right, what is that distance Q. So Q can be determined, the distance D can be determined, Ks cos square theta. So K is 100, which is already given in a problem. S is 2.055, right? Cos square theta, theta is, we are going to have 6 degrees 6 minutes. So if we simplify it, we are going to get the distance, this particular distance from the instrument station to the point Q we are going to get. So we are going to have the distance of 203 point, right, 203 203.18. Okay, so this we have already got it. So this is 203 and this is 229. Now we can determine what is the total distance between P and Q. So we will see what is the total distance between P and Q. So the total distance between P and Q is 432.93. So 229 plus 75, right? 229.75 plus 203.18. So this is what we have done it over here, right? 203 plus 18 plus 229.75. So it is 432.93 is the distance between P and Q. Since the tachometer is set up at an intermediate point, the distance between P and Q is 432.93. Is it clear? Is it clear?
Yes, sir.
Okay. Yes, sir. So our what is the first problem in our this thing is clear. The length of PQ. Compute the length of PQ. Now this problem is over. Now we need to find out the reduced level of Q. We need to find out what is the height, right? What is the height of Q as compared with P. So P RL value they have already given 321.50. Okay, 321.50 they have already given this. By comparing this, we need to find out what is the RL of Q. Okay, so we'll do that. How we will do it, let us see. Okay, so now here distance we have already determined it. Now we need to determine what is the V value for this particular side. So how we are going to determine it? Vertical distance we can determine it by using the formula, right? We are going to use it by V is equal to Ks sine 2 Tt divided by 2. So 1 by 2 we will take it outside. K is 100, right? S is 2.055 into sine 2 theta. Theta is 6 degrees 6 minutes. So we have determined what is the V value. We have determined what is the V value. It comes to 221.213. What is V? V is nothing but from the line of sight, right? From the line of sight to to the center of your crosshair reading. So it is coming up to 21.213. But we have to determine what is the height of Q from line of sight. From the line of sight, what is the height of Q? So that we need to determine it. So we will determine it. How we have to determine it? Difference in the elevation of Q and the instrumental axis. So elevation V minus R. If we do V minus R, R is your 1.895, the center crosshair reading. If we deduct 1.895, we are going to get the height of Q from the line of sight. So here, what we are going to do is, we are going to do 21.713, which is your V value minus R. R is 1.895, so we are going to get it as, right? We are going to get the height of Q from your instrumental axis, right? From this to this, the difference is 19.818 meter. So we have got what is the height of this, right? From the line of sight, and we have got what is the height of this Q from the line of sight. We already have determined it. Now, what we need to determine is, we have determined PQ. Now, the difference in elevation between P and Q. Now, we know that from the line of sight, the P is 32.64, and from the line of sight, the Q is 19.818. So, if we determine what is the difference, between these 2 points, if we determine the difference between the 2 points, right? So if we determine that, and the difference between the elevation of P and Q, that is 32.64 minus 19.818. 32.64 minus 19.818, the difference between this level and this level, it is how much? If we do minus 32.640 minus 19.818, because these are the elevations of P and Q compared to the line of sight. So if we do that, right, what we are going to get? We are going to get the difference between the elevation between P and Q. So the difference between the elevation of P and Q is 32.640 minus 19.818. We are going to get it as 12.822 meters, where P is higher, because RL value of P is 32 and RL of Q is 19. Okay, so P is higher. Now what we want? We want the RL of Q. We want to determine the RL of Q. But how we can determine the RL of Q? We have the RL of P, right, which is already given to us. The RL of P is 321.50. So the RL of P is 321.50. If we reduce what is the difference between P and Q from 321.50, then we are going to get the value of Q. So that is what we have done over here. RL of Q is equal to RL of P minus the difference between P and Q. Okay, so it is 321.50 minus 12 point, right, minus 12.822, which is the difference between P and Q. So here we have determined the what is the RL of Q. Is it clear? Is it clear to all?
Yes, sir.
Yes, sir.
Sir, explain once again.
Yeah. Who is that? Explain once again.
So
Yes,
me.
Suraj?
Yes, sir.
Yeah, from where I need to explain?
Difference in
Suraj,
elevation
from
P and Q.
difference in elevation between P and Q. Okay. Now, what is the P elevation? P elevation is 32.64. How we have determined it? How we have determined it? By reducing from V value. V value we have determined it over here, right? And what is the R value? R value is nothing but from the base to the center crosshair. So this 34.745 minus 2.105, then we have determined it is 32.640. Is it clear, Suraj? Is it clear?
Yes, sir.
Okay. Now Q. For Q, how we have determined it? We have determined it by using this formula. V is equal to sine 2 theta divided by 2. We have determined it. V, right? And what is R? R is 1.895. From this, if we have reduced the R value, that is 1.895, we are going to get it as 19.818. Now difference you want to know. Now 32.640 is nothing but from the line of sight, right? From the line of sight to the instrument station, what is the difference? Now, what is this 19.818? This is nothing but from the line of sight, what is the difference in elevation from line of sight to Q? So this is line of sight is common for both. Line of sight is common for both. So if you reduce 32.640 minus 19.818, you are going to get what is the difference in elevation between P and Q. Is it clear? Suraj, is it clear?
Yes, sir.
Okay. Now, this is the difference in elevation, that is 12.818 is the something difference between, 12.822 is the difference between P and Q. Now, here P is higher. Why P is higher? Because P value is higher over here. So P is at a higher elevation. Then what we want to determine? We want to determine the value of Q, right? We want to determine the RL of Q. Now, from the RL of Q, right, how we can determine it? If we have the RL of P, because we know the difference between P and Q. Now, the RL of P is given to you, that is 321.50, which is already given to you. So 321.50 minus the difference in elevation between P and Q. If you determine it, then you are going to get the RL of Q. So 321.50 minus, well, how much is the difference in elevation between P and Q? Yes, Suraj, can you tell me?
12.822.
Yes, 12.822. So 12 from 321.50 minus 12.822, if we do, we are going to get RL of Q. That is, RL of Q is coming up to 308.678. Is it clear now, Suraj?
Yes, sir.
Okay. For others?
Yes, sir. Cleared. Yes, sir.
B division students, any doubts? Any doubts? B division, I am talking with B division students. Is the doubt is clear? Yes? I want to see some of the B division students. Nandita Patil, you are from A division or B division? Nandita
Sir,
Patil?
A division. A division, sir.
Okay. See, I should not take the names, and if you have understood, right? B division student, your own, you should tell me that you have understood. Srishti, is it understood? You're from B division, right?
Yes, sir.
Is it clear to you?
Yes, sir.
Then I should take your name and I should tell whether you have understood or no. Can't you tell by your own? See, if I am asking some few of the questions, see, if I do like this, my time will be wasted. So I want, if you have understood B division, if I am asking you anything, you should reply at that time only. It should not happen that I should take your name and you should reply to me. Is it clear?
Yes, sir.
Fine. Now we will go for the next problem. Yeah, this is the problem what we want to solve. Okay. In the next problem, right? Determine the gradient from point A to B. Right. Now we want to determine the gradient between A to B. What is the slope between A to B? What is the slope that we are going to get from A to B? From the following observation with a tachometer fitted with the lens. Okay. The constant of instrument was 100, right? The constant of instrument was 100, that is your K value, and the staff was held vertical, right? The staff was vertical. Now, the instrument station is P. This is your instrument station P, right? This is your instrument station P, and the staff will be held at A and B, right? Plane. Okay, they have given the bearings, that is 134 with A, right? 134 with A, and 224 is the bearing with B. They are in the different, they are not in the same line, they are in a different lines. Okay, so that is the reason why they have given you the bearings. Okay, now the angle that the instrument station P is making with A is, that is 10 degree 32 minutes, right? With the A it is making, that is 10 degree 32 minutes it is making. Okay, so this is, and these are the staff hair readings, that is 1.360 bottom, 1.915 middle, and then 2.470 at the top. Okay, so this is what the reading it is making with the staff, bottom, center, top. Okay, then your staff B. Okay, with staff B or at point B, it is having the bearing of 224. And it is making an vertical angle, that is 5 degree 6 minutes. Okay, and the staff readings are 1.605 bottom, 1.885 middle, and then 2.705 at the top. Okay, now here what they are asking you to determine is what is the gradient between A and B. For that, right, if you want to know the gradient, we know the distance D, right? We should know the distance D. Again, the same formulas we will be using, right? Again, D and V, we must require it, right? We need to find out it. Okay, so if the diagram is clear to you, we can move ahead. Is it clear? The diagram is clear. See why I have written A at higher, because the vertical angle it is higher with A, and B I have drawn it towards a lower side. The difference you can find it out, right? The B at a lower angle, lower vertical angle is nothing but the B at a lower elevation. This you need to understand, right, by these particular values. These particular values which have to be at a higher side, which has to be at a lower side. This you need to understand by the values. Is it clear? Can I go ahead? Diagram is clear?
Yes, sir. Yes, sir.
Yes,
Fine.
sir.
Fine. Move ahead. If it is clear, I will go ahead. Now, what I need to do is, again, as usual, what we are doing from P to A and again P to B. We are going to take this part as separate, this part as separate, and then we are going to combine it. So here, we are going to take this particular part, this section from P to A, we are going to calculate. The observation from P to A is, your staff reading is from top and bottom. That is the difference between that is 2.470 minus 1.360, right? It is coming up to 1.11 meter. It is the difference between the two readings. Okay, then D is equal to, again, the C value is not given. So C value, we are going to directly take it as 0. So K, we are having the value K, we are going to have the value theta, we are going to have the S reading. Okay, so here D is equal to Ks cos square theta. D, your K is 100, S is 1.11, theta is 10 degree 32 minutes. Theta is 10 degree 32 minutes. So this particular distance is from P to A, it is 107.3 meters. Now we want V. V, again, as C is not given. So what is the formula? 1 divided by 2 Ks sine theta, sine 2 theta, plus C sine theta. C is not given. We are going to type directly as it as 0. So V is equal to, again 100, again 1.1 S, then sine 2 into theta. Theta is 10 degree 32 minutes. So we are going to get V is equal to 19.95 meter. 19 point, V is equal to this particular height from the center of the crossstaff to the your horizontal line of sight. We are going to get it as 19.95. So we have determined it. So what is the difference in elevation between the A and the instrument axis? That is, instrument axis is nothing but, this is your instrument axis 1.915. So if we want to determine what is the elevation of A, so this minus this, that is 19.95 minus 1.95915, if we do, we are going to get this particular height. Okay, so here it is difference in elevation between A and the instrument axis is 18.3035. Is it clear, part A? Yes, part A is clear to you?
Yes, sir.
Yes.
Yes,
Okay,
sir.
I'll go ahead. Okay, so this is the difference in elevation. Observation from P to B. If we consider this, again, same rules we are going to follow. D is equal to Ks cos square theta. So what is that? S is top minus bottom. Top is 2.705 minus 1.065. If we do, we are going to get S reading, that is 1.64 meters. Then we are going to get D. D is equal to Ks cos square theta. K is, we already know it, it is 100. S is 1.64. Cos square theta is your cos theta, it is making an angle of 5 degrees 6 minutes. So theta value is 5 degrees 6 minutes. Okay, so here we are going to get the distance D between this to this is 162.7 meter. Okay, so 162.7 meters. So V is equal to, right, V is equal to, again, half into Ks sine theta, sine 2 theta. Okay, so here K is 100, S is 1.64, sine 2 into theta. Theta is 5 degrees 6 minutes. So difference in elevation, that is V minus your center hair reading. V is 14.521 minus 1.885. So we are going to get B. So B value is coming up to 14.521 minus 1.885. We are going to get 12.636. All right. So it is 12.636. Is it clear? Is it clear?
Yes, sir.
Okay. Okay. So A is over, B is over. Now what we want to find out what is the difference in the gradient, or what is the gradient between A and B is our question. Okay. So for that, what we are going to do is, what is the distance between AP? Distance between AP is 107.3, and from BP it is 162.7. So here we are making a bearing, right? Now what is the bearing? Bearing is given to you, right? So bearing, for this, again, your survey 1 concept is required. So it is coming in which quadrant? Bearing, it is coming in which quadrant? 134 degree. Yes, first quadrant or second quadrant? Second quadrant. Yes. And your B reading is, it is coming on which quadrant? Third quadrant. So we will draw that. So P to A, I am having, please look over here. So it is it zoomed? Is it zoomed? Is it clearly visible to you?
Yes, sir.
Okay. Now I'll show this.
Yes.
From P to A, it is making an angle of 134 degrees. So P to A is 134 degree. It is making and distance between P to A is 107.3 meters, and P to B, it is making an angle of 134 degree. 224 degrees. So I will be writing it in the which quadrant? Third quadrant. So this I will be making it up into the third quadrant, and then I will be joining, right, this, and I will be joining this. Yes, is there any doubt? Any doubt?
No, sir.
Okay. So I will be joining this line. Now here, as this is present in a different plane, right, I need to make out what is the difference in between the AB, right? What is the distance between AB directly? I need to find it out. Distance, right? These what is the distance between this? So how can I measure the distance? I can measure the distance between PA and PB by having the Pythagoras theorem. I need to determine this diagonal. So this I can determine it by having PA square plus PB square. So PA is here, PA it is 107.3 square, and PB is 162.7 square. If I do it, I will be getting the distance AB. So what is this distance? Distance AB is nothing but the horizontal distance. Distance AB is nothing but the horizontal distance between A and B. Okay, this is nothing but the horizontal distance between A and B. Is it clear to you?
Yes, sir.
Others?
Yes, sir.
Yes, sir.
Okay, fine. So this is the horizontal distance. Since these are present in a different plane, right? These are different plane. Different plane means on a ground level. These are present in a different plane. Okay. So here, what we have determined is the horizontal distance. But what is the vertical distance between A and B, which we have already determined it? What is the vertical distance between A and B? A and B vertical distance is, this is 18.035 and it is 12.636. So if I do 18.035 minus 12.636, I will be getting an answer of, right? 5.399 meter. The vertical distance between 18.035, that is the from the line of sight to the vertical distance to A is 18.035, and from B, the horizontal line of sight to the point B, it is 12.636. So it is 5.399 meter. That is the vertical distance between A and B. Now, in order to determine the gradient, now gradient, how we are going to write it? We are going to write it 1 in 400. For example, I will be writing it as 1 in 400, 1 in 300. So that is, what is that 1? 1 is nothing but your vertical, and what is that 400, 300? That is nothing but horizontal. So what I will be doing now is vertical distance by horizontal distance. If I do, I will be getting an answer of 1 in 36, right? 1 in 36. So why it is I have written it as a falling? Because, right? Why it is I have written it as falling? Because I know the vertical gradient. What is the vertical angle? I already know it, right? So that is the reason why I am writing it as a falling. Is it clear? So gradient, I will be getting vertical to horizontal. So vertical distance divided by horizontal distance. Vertical distance is 5.399 divided by horizontal distance is 194.9. So if I do that, I will be getting, if I calculate it, I will be getting it as 1 in 36. Okay. Is it clear? 1 in 36.1. Is it clear?
Yes, sir.
Okay. So if both the problems are clear, right? If anybody is having any kind of a doubt, they can ask the doubts if they are having any kinds of a doubts. Yes, any doubts? Both the problems are clear to you? Today's session. If it is clear, then we will end up the session. Write your attendance. Write your attendances in your chat box. Please write down the attendances.